Hi there, it's Mr. O again here. Today I'm gonna show you a sample project for your linear programming. So this all of you should have given a unique project, unique questions, and all this project has to be turned in by Sunday, 11:59 through Google Classroom. Nobody should give it to me or email me. Submit it through Google Classroom. Okay. So here is my question. You're a civil engineer designing a bridge. The walkway needs to be made by a wooden planks. You are able to use either Sitka spruce, I don't know what's spruce, Sitka planks, which weigh 3 pounds, basswood planks, which weighs 4 pounds, on a combination. The total weight of the planks must be between 600 to 900 pounds. In order to meet the safety code, if Sitka's plank costs $325 each and the basswood plank costs $375 each, how many of each plank there should be a D, you use to minimize the cost while still meeting the building code? If you're gonna read the rubric, you need to find the problem. I'm not really sure. I think you need to put there the drawing or illustration. I like to have that in word problem so you visualize the situation. You need to start with the variable. So on this topic here, X is the number of what? In this case is the Sitka spruce plank, and the Y here is the number of basswood planks. So in your rubric it says here there should be a problem and constraint. The constraint and for this case here, you know that you're not gonna buy a negative number of any planks. So you have to understand that you need to write here X must be greater than or equal to 0. That means it could have 0 number of Sitka planks or more, or be positive. And also for the basswood could be Y greater than or equal to 0. Okay. Next is that according to the problem is that you're going to have the total weight of the plank must be between 600 to 900. But knowing that each of them has 3 or 4 pounds each, so therefore, what did I do? I lost it. Where in the world? Oh, it's not calibrated. There you go. Sorry about that. There we go. So since we know that the Sitka has 3 pounds and the basswood has 4 pounds, and when you combine them, it should be between 600 to 900, we now can create an equation that 3x, which x is the number of the Sitka multiplied by 3 because there are 3 pounds each, plus 4 pounds of the basswood, because y is the number of basswood, has to be between 600 to 900. If it's between 600 to 900, it could be more than 600, but it also cannot be more than 900, so it has to be less than 900 pounds. Okay, so these are my constraints. So what you need to do here is to graph it. Okay, to make your life simple, I would encourage you to graph it using Desmos. And according to Ellie, what do you call that one again? Screenshot from your Chromebook. Okay, Ellie, go ahead. Go to Desmos. All right, so here, Desmos. Type in Desmos, please. There, enter. All right, so x greater than or equal to 0. No, you don't need it. X over here greater than 0. Okay, then go to the next one. Y greater than over here. Yep, 0. And then the next one here is 3x plus 4y greater than or equal to 600. 600. Okay. Now, if you cannot see the graph, I encourage you to minimize it. Okay, but we will do it later. Go to the next one, ma'am. 3x plus 4y again. Less than or equal to? Yeah. 900, please. There you go. And now we have to see the intersection. So I'm gonna minimize it so I can see the entire graph. All right, you can see it. Where? Let's make it a little bigger. There you go. See this graph? So your point should be, or the intersection are right here. This is your visible region. Alright, LA, do your print screen now, please. Screenshot. Hold on. Before you do the print screen, make sure you show me the equation, show me the 4 points, and that's the important thing. Okay.
I think this is it.
No, not F8. How?
Control-Shift-Split screen.
Louder, Jen. Jen.
Control-Shift-Split screen.
Did you hear that, Ellie? Come on.
I'm looking at it. You have a different computer.
Oh, we do?
Yeah. Yeah, this is like an actual.
Alright, I'll do it. Excuse me. Alright, thank you, Ellie. Alright, I'm gonna do sniping tool. It fast. Oh, obviously I lost the points. Okay. Alright, take the points. Make sure you have that. Boom. 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 Sniping tool. So you all know how to do the screenshot that Ellie's saying? Yeah. Alright. Boom. Copy. And then I'll save it here, paste it here. Paste. Smaller. Come on, where's that? Alright, there you go. Good enough. So, again, Jenan, how do you do the screenshot? Control, Shift, split screen. All right, you heard that one. Okay, so all of you can do that one now. So, but mine, I use snipping tool, so I just copy paste there. Okay, so the next thing to do, so you need to look at the rubric. You have the problem, constraint, the graph with the visible region, shaded and vertices. Objective function. Let's look at the objective function. The objective is like, how can you minimize or maximize? If you're the civil engineer, you would like to minimize the cost. Okay, minimize the cost. How do you minimize the cost? Remember, the cost for each plank for the Sitka is $325, and for the basswood is $375. So therefore, since we need to minimize the cost here, let's use the table. Oh, I don't have space. There you go. Let's go this one. So let's say C of X is equal to, what's for the Sitka is 325 X plus, what's the other one? 375 Y. Okay, that will be your optimizing or objective function. Okay. So these are the prices for this situation. Now, the question is, how many of each plan should you use to minimize the cost? Since we have the 4 points, the vertices are right here. So I need you to make a chart or a table. So the table will give you 0, 2, 2, 5, 0, 150, what else? 200 and 300. 200 and 0. No, this wrong. Come on, baby. 300, 0. These are your vertices. So what you're gonna need to do is you will plug in. I don't need a plug. You're gonna plug in the x and y value to your objective function. So I'll have 325. Jen, calculator, please. times 0. Why is this too big? Let's make it smaller so it will fit in. 325 times 0 plus 375 times 225. 325 times 0 again plus 375 times 150. 325 times 200 plus 375 times 0. 325 times 300 plus 375 times 0. Okay, using the calculator. This will be 0, that will be 0, that will be 0, that will be 0. So Jenan, can you multiply for me 375 times 225, please?
843.
$843 sign. No, not dollar sign. No, but how much of it? No, 343. What else?
843.
843. Oh, my bad. 843.
0.75.
One more time. 843.
0.75.
All right.
And then 562.
562.
0.5.
0.5. Oh, I realized I have it here. Sorry. 975 and 840. Oh crap! This is the worst video, right? And 650, right? Okay, right?
Which one?
For the 0, this is right.
3.25 times 200
No, I'm wrong.
is 650.
Tell me again. Sorry.
3.2.
Okay, I have it here. 0150 is 562.50. Is that right?
Yes.
Okay, it's 300 is 975. No, I'm wrong. I'm hungry. Where in the world?
That's 975. Yeah.
What's this?
That one's 650.
650. You're right. And this is the 975. There you go. Finally. All right. There you go. So which one here are our minimum and maximum? The smallest value over here is the minimum and this is the maximum. Which one do we need here? Remember, we're looking for the minimum cost. So therefore, here is this one here. The minimum value is 562.50 at where? You have to give it the point. The point there is at 0150. Okay? That tells you that this is a feasible situation for you wherein you buy none of the Sitka planks, but you just buy 150 of the basswood. Okay? So I need you, and I hope that Omar won't forget this one, to write that down as your final answer. You're right there. Come on. It's not calibrated. 0 Sitka plank wood, but 150 of the basswood planks. Okay? There you have it. Okay? But you make it nicer, cleaner than what I have done, but at least you know what I'm going to look for your project. And again, read the rubric. Everything's right there. The top portion, again, the problem, constraint, the feasible region, the graph, objective function, chart, like this, and your final answer based on your findings. Okay? There you have it. Kaboom.